Okay. All right, I'd like to kick this session off. So welcome to the second half of the tooling developer tools section. So our first speaker in this session is Josh Ballanco, and he's talking about Julia's secret superpower, which if I remember correctly is REPL and lessons from other languages. So.
Yes. Thank you. And thank you all for coming to the talk. So yeah, today I want to talk about what I believe is Julia's superpower, the REPL. And in particular, I am hoping to share with you things that I've learned along the way working with other languages that have slightly inferior REPLs. But I wanted to start off, actually, with one of my favorite quotes about programming from the venerable SICP. Programs must be written for people to read and only incidentally for machines to execute. Now, the reason I like this quote is because the first time I encountered it, I thought it was garbage, right? Why am I worrying about other people reading my code? If I wanted to talk to people, I'd write in English or whatever language they happen to speak. I'm writing code because I want to make a computer do something, all right? But over the years, as I got older and hopefully wiser, I came to appreciate the wisdom of that statement because human languages are imprecise, and computers don't speak human languages. I know we'll get there, but so if you want to program a computer and do so in a way that other people can understand what you're doing, you need to make sure that the code that you write is readable by humans. And the computers don't really care, right? Because a computer is perfectly happy reading this. I would venture to guess most of you are not as happy if you were having to read this, and not so many people are programming in assembly anymore. I think we would prefer to read this, which is the exact equivalent to what was shown before. And the reason I wanted to start with this little sort of diatribe about Abelman and Sussman's quote is because the conclusion I draw from this is that programming is a creative act. Much like composing music or painting a painting, it's creation. And much like those, creation thrives on iteration. So I want you to imagine for a moment if the writers of your favorite television show, when they came up with a new joke, had to write out the script, give it to the actors, have them practice their lines, record it, edit it, and show it to a live studio audience, only to find out that they didn't laugh, go back, and try another joke. Not exactly practical. And yet, most of us are doing that exact thing every time we program, right? We sit down, we write something, no idea if it's going to work, compile, it compiled, great. Is it going to run? Right? It really takes you out of the creative flow when you have to break up your iteration process. Even if your compiler is fast, your runtime is fast, it's still an interruption. Luckily, we do have a tool available that is much faster, and that is the REPL. So, as I'm sure most of you are probably aware, REPL is the read, eval, print loop. The name comes from the three functions in the original Lisp implementation that were chained together in order to achieve a REPL. And just so you're aware, I'm not going to be going into sort of the Julia REPL 101, though you should be aware of it. If you haven't played around with the Julia REPL, it's a wonderful REPL. It obviously can evaluate code, but you also have these additional tools like typing semicolon to get into a full shell, right? Using the square bracket to manage your packages, create packages, right? And the question mark to get help not only on the core utilities, but on any package you might have included, right? Which is really useful. So I want to challenge you now, though. So what is a REPL? Well, this is probably what most of you are thinking, and you'd be right. What about this? So if I can convince you of one thing today, I'd like to convince you that your text editor is a REPL. Why? Well, because in that original definition, there was no qualifier that you have to read from a terminal or that you have to print out to a terminal. anywhere you can read from, you can evaluate in the process, and print back out to, that's a REPL. Okay, does it have to be Emacs? Well, after almost a decade of being a Vi hacker, I came around and have been using Emacs since. Other editors will work. The qualifiers I would give you is that you should make sure that whatever editor you're using has a tool set that's able to send content from your text buffer to the REPL process, that can take the results of evaluating back from that REPL process into a buffer. And the last one is kind of a bonus. I find it useful occasionally to be able to actually take some code, evaluate it, and replace that code in your buffer with the results of the evaluation. For example, this is really good to expand macros in place, debug them, find out why they're not working, and go back. Okay, before we get into the exciting part of the talk, just wanted to give you a rundown of some of the tools that I'm going to be showing you. So first of all, if you are using Emacs, you definitely should be using Julia Snail. It is a wonderful library. I cannot sing its praises enough. I happen to have whipped up a quick fork because it has the basic send to REPL and display, but not the dump into buffer, and I just wanted to play with those today. So you can find my fork there, and I'll be contributing it upstream. I happen to use Doom Emacs for configuration, to each their own. If you haven't used Emacs and you want to get into it, it's a very nice, gentle introduction. I also put together a library that we'll see in a moment that I call Elegant REPL that has the secret sauce. And finally, unfortunately, we don't have so much time that I can get into all the nitty-gritty details, but I do want to point out that if you are using Emacs and you start it in server mode, set your Julia editor to Emacs client. Doing this allows you to actually use the edit macro, for example, and have whatever you want to edit open right there in the same editor that you're already in. It's really a wonderful workflow. Okay, so the second, or the secret superpower, and this is the second thing I'm trying to convince you of. It's something that after being a Ruby and Python hacker for many, many years, I finally got a chance to work alongside some real Clojure heavyweights. And I saw the way that they worked, and it really opened my eyes. And this is really the reason I wanted to come here and give the talk and share it with you. So here it is. You can laugh. It's nothing, right? But that's the point. So what does a macro like this do? Right? We already have line comments. We already have block comments. Why would you have a macro comment? Well, it turns out when you put code inside of a macro comment, it must still be valid Julia syntax. And because your editor doesn't know that the macro is just eliding the code, it's still going to treat it as Julia code. It's going to highlight it. It's going to format it. But because you basically can operate without consequences, you can do whatever you want within the comment block, send it to the REPL doesn't know it's in a comment block, right? So if you just send a couple of lines from a comment block, it doesn't know that it should ignore it. It will evaluate whatever you send. And again, because it doesn't exist in the compiled code, you're free to pipe whatever you want. It's a sandbox to play in. Okay, so how do we use this power? Well, the ways that I've seen it used are it's very good for inline documentation, right? So how many of you have ever read through some code and you see embedded there in the doc string of a function a markdown block with Julia and a bunch of code, right, that you can't run because it's in the middle of a string, right? And it's not highlighted and it's not necessarily formatted. You have to copy it out, do something with it. Instead, you can put a comment block above your function with some examples that you'd like people to run. A very common use case that I've seen when I was doing a lot of Clojure is when you have database connections or servers that need to be initialized, right? A lot of times you don't want to have to go through that process every single time just to get to the function that you're trying to operate with. So you can put that initialization code in a comment block so that when you're in the file that you're working in, you can just really quickly evaluate that code, boom, you're ready to go, and you can be off to the races. It's helpful for debugging suggestions, right? So, you know, you can put something in a comment block and say, just eval this code and see what the results are, right? You can use it for inline scripts, right? So I've seen source files where it's a bunch of functions and then a comment block with, you know, these are the orders to call the functions in. But most importantly, it's good for exploration. Okay, so assuming we've done the appropriate sacrifices to the demo gods, let's try and code. Okay, so first thing I'm going to do is I'm going to start up my Julia snail process. And then the next thing I'm going to do is make sure that the project is activated. Okay, so what I've done is I've taken some sample code from documentation from some popular libraries. And I wanted to see what it would look like to use this tool and sort of the editor as the REPL to work with these. So this is from plots. And the only thing that I did is I imagined, instead of just being a series of lines of code, that it's some sort of function that I'm creating where I'm setting up a bunch of plots, right? And I want to make sure that the plots that I'm creating have been set up correctly. Now, you can't ship this code, right? Why not? Well, I'm going to evaluate the buffer, and you can probably predict what's going to happen. There's the plot. Now imagine you put this in the library. Every time somebody tries to run your code, or even include your code, they're going to get a random plot showing up. That's not good. But it is kind of useful to have that, right, to make sure that I'm on the right track. So here's what we would do instead. Take this up here. Evaluate that line, so we got the library in place. There's our example. Okay. So now, you can see we can, again, I'm going to, one more time, evaluate the entire buffer. No plot, right? We're safe. But if we want to see that we are actually doing the right thing, we just come up here, evaluate that line. There's our plot again. Okay, so pretty simple, but it gets better from there. Okay, so here's a slightly longer example that I took from the HTTP library. And this is an example that's trying to give an idea of how you might write authentication middlewares for a server, right? Now, I'm not going to evaluate this buffer, because if I do, I'm going to get into trouble. I'm going to have to restart the REPL. It's going to be a problem. But we can already look and see why that's the case, because we have here some function called parseAuth that doesn't exist. And we have some function here called getUserData, which doesn't exist. And the last line here is a blocking call to start the HTTP server, right? So not good. We can't just evaluate this. But what we can do is we can set up a comment block. So first thing, let's copy this here. Okay, and now we're going to start playing, right? So this is where the creative iteration begins. So first of all, I know that I don't want to do the blocking serve. I want to do this. Could have looked up the documentation, but we'll save some time. And I'm just going to assign it to something. Oh, I forgot to evaluate the buffer, which I can now do safely because everything that's not defined is hidden in this comment block. Oh, or not, because we'll try this again. Okay. All right, so now I can evaluate this line. Oop, all right. Got to start that again. Okay. All right, so evaluate the buffer. And now evaluate the line. So now we have a server, okay? And to prove that we have a server, I'm just going to evaluate this variable. But this time, I'm going to use a slightly different way to evaluate it. I'm going to have it dump the contents into the buffer. So there we go, right? And now I'm free to inspect this, do whatever I want, look at whatever I need. I also know now that I can, say stop, evaluate that line. Oop. I think it's HTTP. Close. Close, thank you. Right, so there we go, right? And I can, again, start it back up again. Right, so this is how we can, imagine this is a much more complicated server initialization. We can put this in a comment block, have it there, ready for us to use. Okay, but now I'd like to make a request. Okay, so I know there's a thing, HTTP request, but what am I going to do? Well, luckily, Snail has the ability to pull the documentation right up here, which is really nice. So I'm just going to skip ahead, and I know that I need to make a post request. So let's go ahead and do that. To the server I just started. And for the time being, we're going to send some empty headers and an empty body. Okay. So now I can dismiss the documentation window, and let's evaluate that line and see what happens. Boom. Everything blows up, right? Of course it does. We are referencing two functions that haven't been defined yet, right? Okay, but that's okay. Now we can see what they should be, right? So first thing here is we need a parse auth. Okay, so that's the first thing that showed up in that stack trace. I don't have a parse auth. Maybe eventually I'm going to pull in parse auth from another library, but I don't want to do that right now. I just want to see what I need. And it's getting a request. What should I do with the request? Don't know. Let's just show it for now. Okay? So now I can evaluate that region. I have a parse auth function now. It's in scope because I'm in the module scope for this. So now I can evaluate this line. I'm still going to get a 500, but now if I come down to my REPL buffer, I can see, the request, right? This is the thing being passed in. So I should do something with it. Okay. I'm going to skip a few steps ahead, and I'm going to say, I know that what I want to do is I want to say if the request headers authorization is set to, actually I'm going to do this. Okay, now first thing, you notice, even though this code is not appearing in the final product, it's still being parsed by my editor. So it caught my typo, right? Can't do that in a string. Okay, so now I can evaluate that, and that's going to update that function. So now I can, again, come back to this line, right? And notice I keep coming back to that line. It's very handy to have there to just go up, eval. This is that quick iteration process, right? Okay, so now what's the issue? Okay, so now we're getting this method about, oh, right, of course. Invalid index authorization of type string, right? Oh, okay, geez, I would have thought that the headers would contain a thing called authorization. But look, I can do this. I can say, ooh, let's do this here, show request headers, and again, reevaluate, and again, reevaluate. And now look down here. Ah, right. It's a list of pairs. If I want to index by the key, got to turn it into a dictionary. Okay, so first we have to surround this. Okay, so now we have a version of our function. All right, let's try that again. There we go. So parse auth, and again, evaluate the line, and now come down here, and, oh, authorization. Oh, right, of course, authorization's not found because, why? Because I didn't set it. Now I can evaluate that. And now I'm getting a different method, or a different message, right? Now we've gotten past the parse auth. Now we say get user data is not defined. Okay, so that's the next one. Well, let's do that. Okay, so again, I'm not sure what ident is, so let's just show it initially. This way I can get a feel for what it is I need to do. Come back up here. Okay, so ident says Josh is authorized. Okay, so let's see, what can I do? I can say if ident, oh, again, catch the typo. So again, I can reevaluate that function. Again, every time it just updates the same function. And now I can come back to the same line I've been using, evaluate the line, and now I've got an OK, right? Now, did I actually get my response? I don't know. Let's assign it, evaluate this, and dump it. Ooh, OK, yeah, it comes back as binary, so let's do this. Nice. Okay. So this is an example of different things that you can do to play around, right? Be creative. I did want to do one last thing, though. So there is one additional hidden superpower in Julia, and that is Julia's types, right? And I think it's something that we haven't really completely taken full advantage of. So one thing that I was doing while preparing this talk was playing around with what would happen if I took the ability to look at the types of everything in a context, in the REPL, all the methods that we could use with that, and give it to a process that might be able to do something with it. And now I'm going to use the version of sending to the REPL where I replace the line. Oop, all right. Spoiled the surprise, I forgot. So I figure probably most of you, like me, are giving Anthropic $20 a month. I gave Apple a heck of a lot more money for this thing, and it'd be really nice to use that. So there we go. And it does come back as a string, so that's one thing that I still have to work on. But yeah. So right there on my own machine, I was able to get code generation out of Quen using the ability to inspect what's in the REPL. So, okay.
So I've used this thing called Vim Slime or something, which you can send code from your window to a REPL.
Yep.
But with your snail thing, what that enables is the bidirectionality and these things, or?
Yes.
And is it specific for Emacs, or what do you have to? What does an editor has to support to use the?
So
package?
Julia Snail is specific to Emacs. So there's a couple of ways that you can do this, right? So depending on your editor and depending on your REPL, you can either do it the hard way and basically parse out the terminal output, right? Always copy to the terminal. Basically, what you would do with a copy-paste, you can automate via the editor. The way that the Clojure folks do it, and Julia Snail does it, is you actually open a port at the same time that it just accepts I/O and runs the eval and responds back to the same port with that I/O. And then Emacs is really amazingly competent at doing I/O and all kinds of crazy things. You can actually do Julia Snail over SSH to a REPL running on another machine. So.
Thanks.
Yep.
We'll see.
Would you still do it this way if, let's say, Snail supported org Babel better?
Say again, sorry.
If Snail supported org Babel.
Org Babel.
Better?
Snail does support org Babel. So yeah, I guess I should say there are other ways to do this. Because time was kind of short, I had to remove all the comparison slides. So you've got Jupyter Notebooks, right? But Jupyter Notebooks you can't package up in a library and ship very easily. Org Babel is very good. Usually there's a step where you have to strip out the stuff that's not the code, right? So the idea of doing things this way and with the comment macro is that this is pure code, right? It's not a notebook, it's not a doc, it's not anything. It's just pure code. And at any point in time, right? So if you're preparing a library, you know, you're probably going to take care to package it up and make sure it all looks nice. But if you're trying to ship something to production, you know, before the end of the day, you know, and you don't care that some of these comment blocks get left in there, this is really, really useful.
All right. I think in the interest of time, we should move on. Let's thank our speaker again.
Thank you.